definitely gonna have to check me
Yeah,
here.
that's it.
Times 1 plus square root of x, right?
What?
I think it's just x.
Yeah.
1 plus x.
Oh yeah,
No,
because it's squared.
Yeah, 1 plus x.
See, I knew I was gonna screw it up. Okay, verify that. Now I got your attention. I see that smile on your face, Andrew. I wondered why y'all were just sitting around. You forgot the whole verify thing. You just went straight to memorize formula in book.
Did you take homework? Did you mark that down? Or
No, I'm probably not going to get around to it today.
Okay.
I'll do it on Thursday.
Can you define arctangent for me again?
Inverse tangent. All the y's become x's and the x's become y's on the tangent.
Thank you.
Yep.
Is that denominator 2 square root of x times 1?
2 square root of x times 1 plus x. And they tell me it's right. I'm going to trust them till I realize they're wrong.
I think I got it.
You did your homework. That's awesome.
I'll go tell you again.
Yeah, I know, I saw that. Good work. So did you find your question? Did you find a question you couldn't
I
find?
have no idea where to go from here.
Looks like you may have been the only one that did your homework. Everyone else was thinking hard. Maybe Robert did. Robert, did you have this stuff? Let you equal one tangent of the x. Let u equal arctangent of square root x. Let u equal our derivative thing, our d dx thing.
What is the derivative of that?
You then move the tangent over by the u and let tangent u equal root x and derive implicitly.
U?
Step 1,
Oh.
let u equal the stuff we're deriving.
Oh. I thought it was Y. Yeah.
Well, let y equal, who cares?
Damn.
It's just a variable, yep.
Whenever you say U, I think you sub.
Well, don't.
Damn. Okay.
Step 2, move the tangent over. Step 3, derive implicitly. Implicitly. You're also going to build a triangle somewhere along the way. You can do it as step 4 or not. Build triangle and use SOHCAHTOA. And Pythagorean theorem, I guess, too. 2-timing it. If you do all those 4 steps, you probably got it. You got it now, Andrew? All right, good. Did you do the homework yet?
Yeah.
All right, awesome. You and Ben, maybe the only 2 that finished the homework. Did you do it?
I did the homework, but I have a question on this. Yeah, I'm kind of lost. Because I did the same thing here. So, 10y plus 30u. Opposite for hypotenuse. So then I solve for this side, which gives me this. So then you times that by your original u over 1 times square root of y. I mean, times tangent.
Okay, so hold on, let me see. Tangent y is equal to times
This. Yeah, because I thought that was
okay, so where we're deriving. Have we derived anywhere yet?
This is the derivative. Because that's what we did for this last one.
Right, but you're deriving this thing.
And the tangent's O over A.
So that's secant squared y dy dx.
Right.
Oh. So I just erase all this.
I'm trying to see, yeah, okay, so on this step where you were deriving, somehow you did not derive, I don't think you derived tangent y correctly,
Oh.
and I certainly don't think you did any deriving of square root of u, and you needed to do that too.
Yeah.
It's probably the square root that threw you off. Did you get it, Reed? Not yet? That's fine. You can, this is, I mean, you just saw that one problem we did. Three methods we came up with.
Your secant squared. Whenever I get my hypotenuse side, what do you get when you get your hypotenuse side, Josh? Okay. Okay, what have you put the
I'm so
triangle?
dumb. I forgot the original thing. I forgot to derive this. So now I have to restart.
Wait, what's your secret?
That's your prime, yeah, I know, I see that.
Yeah, one over
So that's jumping straight to the concept.
Oh, yeah, right. Derivative of tangent is just secant squared, right? Right.
Okay, yeah, so this is jumping straight. So I want you to build.
Yeah, that's what I did. So you have your angle y, or u, or whatever.
Because this is just chain rule.
So opposite is root x, adjacent is 1.
Formula.
Right.
Okay, so are you
And
doing
then use
okay with
Pythagorean
building
theorem to
this?
get your hypotenuse.
You getting there?
Yeah, I got that.
Okay, keep going. Nick, where are we at? Robert, did you get it? Not quite?
Cosine. See, cosine is hypotenuse over adjacent, since the secant is, so, right, so it's h over a.
No, it's not, this is gonna end up being down with secant squared.
Oh, yeah, you're right.
Okay, which is what's gonna give us that 2 root x in the bottom on our answer.
Okay. So then that is, okay.
Alright, you can take it from there.
I think so.
Second one over this one.
Is x plus 1.
Right.
Oh, wait a minute.
Yeah, secant is 1 x.
Yeah, I'm good.
What's up? So do you end up with like a secant squared y?
So,
For the derivative. Secant squared y equals 1 over 2 root x.
Secant squared y dy dx equals 1 over 2.
Yeah.
Yeah.
And then you just solve for dy dx?
Yeah.
Oh.
Yeah, so you just have L over x. And then you use Pythagorean to find the other side. And then you do the same thing to find.
Brandon, where are we at?
He did for certain problems, yeah.
1 over 2 root x.
And cosine squared plus sine squared equals 1. And then whenever I'm trying to solve for, I solve for in that equation.
Derived, except for you forgot to
And then
write.
like, this example, like, so this is what I have, and I wanted to get secant.
Oh, that's what you did.
Right, so it's 1 plus tangent squared y equals secant squared. And then so I plug that in, tangent squared y, or tangent y is up here, which is the square.
Whatever secant squared u is, your triangle. Aaron, where are we at?
Cosine.
Alright, good, so far so good.
Oh, like you did the derivative and then
Plus the derivative of
That's
square
Sam
root.
taking.
Adjacent over
That's Sam taking.
hypotenuse.
Yeah.
So
So equals 1 over 2 square root x. What you have there is
cosine
triangle equals. Yeah, you got a mess there, right, Albert? Put a 1 under the secant squared and flip it.
cosine of 1 over 1 plus x.
You're just gonna create a right triangle. We said that tangent y was square root of x. That
1
means tangent
over.
y is opposite over adjacent. So pick an angle to work with. Yeah. And that would mean the opposite side is square root of x, and the adjacent side is 1. 'Cause we've got root x.
Physics is a lot of like, this
Yeah.
is do one thing, now interpret the rest.
There you go. Now use the triangle. Build me a triangle where you know.
I think how
I get
tangent of
1
y is supposedly square
over
root of x.
2 root x.
So
I
apparently
got it.
x, which is opposite over hypotenuse.
Yeah, cause it's like, yeah.
I hate my life.
I mean adjacent, opposite over adjacent, thank you. Would you agree that the tangent of anything is opposite over
What's the
adjacent?
hypotenuse?
So if
Root
y is
1
opposite
plus
of
x.
Right,
square root of x
right.
must be the opposite over
I just looked at the triangle, there's no variable there.
x over 1. Opposite side, adjacent side.
That's why I was late, cause I actually got something to
You
eat.
might wanna write it. Get your red pen out.
And when you do adjacent, will you do underneath the angle? Oh, I guess that would be.
Cause I was gonna show
The slopes like I said you could try.
Wait, what I do for this? So I got
Oh,
this.
and
And then what I multiply it by.
Okay.
I just
You lost it
square
y
it.
dx. But where's your derived function?
I'm trying to be healthy, but I'm
So you take the derivative, so that's that, then you need dy dx there. And then you solve for dy dx.
Oh, wait, and then
And what, yeah, that's not right at all. You didn't take the derivative of the right side. Because this is secant squared y, you took the derivative of the left, but you didn't take the derivative of the right. The derivative of that is 1 over 2 root x.
I had 1 egg with a little bit of
That's what our.
So then you solve for dy dx because that's what we're asked to find.
So then this is 1 over 2 root x.
You gotta do this first.
What?
Is this side 1 over 2 root x?
Oh, really?
No, it's just root x.
Later, but first,
Because like,
step one,
that's your
let y
derivative,
equal
this
our
is your normal
tangent of x,
triangle.
stuff we're deriving.
So that should be root x.
Step
Well,
one.
I just like using the
Okay.
See that derivative
That's fine.
arctangent
And then you
of
use
x?
the Pythagorean theorem to find that
Don't
side.
let anything phase
Okay,
whatever.
so,
So I multiplied this.
Then,
and
step
that.
2, move the tangent over by the y. Step
So,
3, derive
you need to
implicitly.
find dy dx, basically.
Step 4, building the
So you
triangle
have
is the trickiest
secant squared
part.
y
You can do
dy
this
dx
first 3 steps.
equals,
Alright, that's all the time I want to spend on this one. How many of us feel like we got it well enough and we've taken good enough notes? Have you taken enough notes to understand what you just did? For Christina, you might shoot your paper so she can see a completed problem.
okay, it's kinda
And-
sloppy.
Well, shoot somebody's paper.
Sorry,
How
Christina.
sloppy is yours?
Moderately.
I could read that.
Because we're gonna do the same game with the triangles, only we're going
Sorry,
to step it up a
Christina.
notch.
Okay.
5.7.
Oh, do I hate my life.
Let me see. How about number 34?
5, 6, or 7?
Yeah, because 34 is gonna make us complete a square. Well, let's not start with 34.
Yeah,
Let's
so
start
it'd
something
be-
easier. Let's do number
Well, I would flip secant to 1 over cosine squared.
12.
And so I would multiply this to cosine squared y.
Should do when you've got answers in the back.
How do I know?
Okay, 5.7, number 12. We're gonna use it to talk about our ideas.
Bet.
The integral 2 over x square root 9x squared minus 25 dx. Okay. We're going to verify that our integral is what it is. So when you see a minus u squared inside a square root, what do you think?
Split it.
Think? Well, let me be more explicit. When you see that, what are you going to think about? deriving things, look at your formulas if you need to. Deriving what thing would give me an answer of 1 over square root of a squared minus u squared. 1 minus u squared. Okay, let's back it up a little bit. There are 3 formulas that
Arc
we're kind of
sine.
playing around with today. 1 minus u squared is the simple form. U squared minus 1 is another one, and 1 plus u squared is the third one. Those are the key elements inside the square roots or denominators or both that we've been working with. We just worked with one.
Or something.
Yeah, they're the arc somethings. So, all right, let me ask you this way. What's the derivative of the arc sine? Quick, use your formula. What is it?
1 over square root cosine.
1 over root x.
1 plus u squared.
Nope.
1 minus u squared. Oh yeah, u squared minus 1.
Well, u is x.
Oh.
And u's derivative is 1. And x squared is x squared. What's the derivative of arctangent of x? And u is x. What's the derivative of arcsecant?
Absolute value times square root of x squared.
None of this makes sense.
This 5.6, the one we just finished, we're taking advantage of these rules. We were verifying one of these 3 rules. We were actually verifying the tangent rule. Okay. What's the derivative of sine of square root of x? Derivative of u, right? Square root of 1 minus square root of x squared. I'll stop while you think. How many of you see what's going on with that one? Who sees it, yes or no? If you don't, shake your head, no way, I don't care what's going on.
I don't understand the bottom.
Oh, yeah, lied.
I was about to say, what?
Whoops. Nice catch, Nick. The rest of you are like, no, that's not what the derivative of sine is. All right, now, who knows what's going on? Still nobody.
I haven't caught it. I don't understand the bottom.
So you're subbing it into like, yeah.
I'm just subbing it into the formula.
Oh, okay.
Because the formula, y'all were afraid that I didn't put u's. Watch it, magic. Just became a u, which means this is a u prime, which means this is a u. In terms of x, see how that works? Who asked me the question about the u and the x? Yeah, you did. There's the u in terms of x, so our u's are in terms of some x equation. So this one, uh-oh, magic again. Goodbye, x. See you later. U prime, u. Chain rule. That's why that u prime shows up. It's a chain rule. U prime, u. Those are just formulas. We have to verify all those formulas. That's what you're doing in 5.6 is verifying those formulas. And I need you to do that so that you'll understand what to do with 5.7. Maybe we need to not jump so fast to 5.7.
Yeah, jeez.
You think?
Who's okay with 5.6?
Yeah.
The stuff we were just doing a minute ago. This stuff. Raise your hand if this. Hi, I want to see where we are. Hi, if you get this stuff.
I could use more.
Okay, so that's not even half of us that feel that way. And
My hand's slightly off the table.
I understand some part.
Yeah.
Jesus, you get it?
So if you get 5.6, let me see, how much is this gonna mess me up if we take another day?
Let's do it for Christina.
She heard that on the video too.
She'd be aight.
Yeah, what the heck?
Bet.
Okay. If you know what you're doing, do your homework in 5.6. If you've got your homework for 5.6 done, get started on 5.7. It's not that hard, especially if you've done it before. That would be you and you who know what you're doing, right? Okay, so just get working on 5.7. We're going to do a couple more examples. We may get to 5.7 later today, but you are not ready for 5.7. You are like, phew!
Yes.
If you want to work on this example and I'll walk around and help you too, so that you're good to go, we can do it.
Okay, so what are the rest of us doing that don't know what we're doing?
You're going to verify this.
Oh, okay.
Wait, so if we do know what we're doing, we verify it.
If you understand 5.6,
Do 5.6 homework.
try this problem. It's 5.7, or do 5.6 homework. If you know what you're doing, just work on the 5.6 homework. If you've already done the 5.6 homework, start working on 5.7 or try some more 5.6. If you haven't got a clue what's going on, verify that problem. It's part of 5.6. That would be most of you are verifying arcsine of x, square root of x's derivative. Building some more triangles, in other words.
Yeah, I don't list them.
Before you do that, don't do,
Oh, just make them up. Just choose some. I don't have the list either.
Or you
Pick
can pull
some.
the two out, what am I thinking?
Why do you?
make sure they're all on numbers.
Okay.
Unless, what did I say online? Maybe we'll go with,
For
I
5.6?
don't remember if I have any on 5.6.
5.6, you said 30.
You just work. I'm talking to people who are already, in other words, those who don't have anything else to think about, I can give you assignment for 5.7. The rest of you, work, dang it, work.
I have no idea what's going on.
There, of course, oh, I forgot to delete that other course document.
No, we're doing that one. I'm just saying, like, having a rough go at this. Y equals sine 1 root x.
5.7, oh yes I do, 1 through 49 odd.
Okay, so sine, so opposite over hypotenuse.
Let's make that every other odd, shall we?
They're weight
Yeah,
now,
I think
so I
we
get
need to change that.
sine 1 equals root x. So this is angle 1.
Okay.
Opposite x over hypotenuse, which is 1.
Decrease your surplus population by your
Plus c
I think I'll do every other odd in 5.
And they are not funny, they said it's not
minus x root.
Andrew, 1 through 49, every other odd in 5.7, not every odd.
Okay.
We'll follow we're finally caught up to the curriculum online.
Starting with 1.
Do I have like a little pinboard right
Starting
here?
with 1.
Like right on my lip.
Actually,
I'm alright with that.
regular hides the implicit.
Professor.
Alright, y equals 2x. Derivative of y is 1. dy dx. And this is 2 dx dx. Hey guys, that's a lot of noise for people verifying this thing. You were a little lost a minute ago. Do this problem. If you don't know how, call me over or talk to someone who does. Who knows how to verify? Raise your hands if you've got an idea how to verify this. Raise your hands because I want you to be helpers.
Kinda.
That would be Andrew does. Merriman kinda does. Ben's not willing to admit it.
I got
Austin
a
does.
question. Why do you have...
I'm talking to over here for a second. I just want you to tell y'all to shut up. Okay.
Damn,
So then it
Professor.
ends up being dy dx equals 2. It's implicit too. We're just not telling you. However, if we put x's and y's together, or even like this, it's plus 2y dy dx equals 1, and then we solve for dy dx when we can.
That's a stereotype.
All right, Austin, what was your question?
Why do you have that written as square root of 1 minus x, square root of x squared? Couldn't that just be 1 minus x?
I'm fitting it directly into the formula.
Oh.
Derivative of the inside times square root of 1 minus the inside squared.
Okay.
Did you get it? Did you get it? You misbehaving people.
She's stereotyping men.
He disagreed.
Alrighty. Now,
Check the tape.
are you verifying or not? Get. Yeah, that's true.
dy dx equals negative 1. Oh wait, it's right here.
Over here, stereotyping. Okay, you might be right.
Peter's gonna ask that we never video again. Please don't do that again.
I was doing this one. I did 5 equals 3. Alright, so that's if you're verifying it, you're gonna have to throw some trig in it. Don't forget you're doing some trig. You want 5u to equal, you want things to equal this. I'm going to see what it is. No, it's not gonna work out clearly for you. You can use a secant, an inverse secant. Can you see the format? X outside, X inside, X minus. So do you see b squared minus a squared?
Wait, don't arc secant?
Is that right?
Yeah, so we're gonna get even trickier than this. If we put an a in there, that's what we got going on here. This is bigger than 1. This is simply a slightly simpler formula without.
Yeah.
Secant to secant to over 2 squared.
I
don't know if I see this.
See, now you can do secant to cosine.
Oh wait, no, you take the square root and then.
And then, cosine, or, secant is hypotenuse over adjacent, right?
Yeah.
So, if you want, you can go ahead and take that, because your angle is y. So, like, that's why I draw a triangle.
Yeah.
So I know that the adjacent is this, and the hypotenuse is this.